Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 68. So I'm going to first start by rewriting 8 as 2 to the power of 3. So I get 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 68. Now, I'm going to rewrite 2 to the power of 3 to the power of x as 2 to the power of x to the power of 3. So I have this plus 2 to the power of x is equal to 68, and I can do this because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. Now from here, I'm going to let 2 to the power of x equal to the variable y. So if I substitute in y for 2 to the power of x, I get y to the power of 3 plus y is equal to 68. And now I can subtract 68 on both sides. So I get y to the power of 3 plus y minus 68 is equal to 0. Now, to actually factor this and find the value of y, I need to first find the factors of 68. So the factors of 68 are 1, 2, 4, 34, and 68. So now 1 wouldn't work because 1 times 68, we can't subtract those two to get y. And 2 wouldn't work either. The only one that would work is 4, because if you divide y minus 4 with y to the power of 3 plus y minus 68, that would be factorable. So now that we know that 4 is a proper factor, for my original equation here, y to the power of 3, I'm going to rewrite this as y to the power of 3 minus 4y squared plus 4y squared minus 16y, which is 4 squared, plus 17y, because negative 16y plus 17y is equal to y, and finally minus 68 at the end is equal to 0. Now I'm going to factor by grouping. So these two are a group, these two are a group, and these two are a group. From y to the power of 3 minus 4y squared, I'm going to factor out y squared because that's the greatest common factor. So I get y squared times y minus 4 plus, from 4y squared minus 16y, I'm going to factor out 4y, so I get 4y times y minus 4. And from 17y minus 68, I'm going to factor out 17, so I get 17 times y minus 4 is equal to 0. Now if I factor out y minus 4, I get y minus 4 times y squared plus 4y plus 17 is equal to 0. And now this gives me two equations. I get y minus 4 is equal to 0, and I get y squared plus 4y plus 17 is equal to 0. So for y minus 4 equals 0, add 4 on both sides, and I get y equals 4. For y squared plus 4y plus 17 equals 0. I can factor this by using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, a is 1, b is 4, and c is 17. So I get y is equal to negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 17, all over 2a, so 2 times 1. This is equal to negative 4 plus or minus the square root of 16 minus 68 over 2, which is equal to negative 4 plus or minus the square root of negative 52 over 2. and this is equal to negative 4 plus or minus the square root of 52 times the square root of negative 1 over 2. And the square root of 52, this can be simplified to, well, 52, that's 13 times 4, and 4 is 2 times 2, so this can be 2 root 13. So I get y is equal to negative 4 plus or minus 2 root 13 times the square root of negative 1, which is simply equal to I, over 2. Now if I divide both terms by 2, I get y equals negative 4 plus or minus the square root of 13i. Or sorry, negative 2 plus or minus the square root of 13i. So now that we know these values of y, remember how we let 2 to the power of x equal to y, meaning I get 2 to the power of x equals 4, and this is obvious, x equals 2, so that's one solution of x. And I also get 2 to the power of x is equal to negative 2 plus the square root of 13i, and 2 to the power of x is equal to negative 2 minus the square root of 13i. Well, 2 to the power of x, we can't take the power of a positive number and make it equal a negative number. So there's no solutions for these two, and x equals 2 is my only solution to this problem. Alright, so in this problem I have m minus n squared is equal to m squared minus n squared. So to solve this problem, I'm going to first start by rewriting m minus n squared. And I'm going to rewrite this to m minus n times m minus n. Now from here, I'm going to expand this by multiplying these two. So to multiply these two, I'm going to first start by distributing the m. M times m is m squared. M times negative n is negative mn. Now I'm going to distribute the negative n. Negative n times m is negative mn. And negative n times negative n is positive n squared. So I have this is equal to m squared minus n squared. Now, I can do a few things here. I can first start by subtracting m squared on both sides, so this way these two m squares cancel out. And now I'll be left with negative mn minus mn plus n squared is equal to negative n squared. Now negative mn minus negative mn is equal to negative 2mn. And then now if I subtract n squared on both sides, these two cancel out and I get negative 2n squared. Now from here, I can divide both sides by negative 2. So then these two negative 2's cancel out, these two negative 2's cancel out, and I'm simply left with mn is equal to n squared. Now from here, I'm going to subtract mn on both sides. So then these two cancel out, and I get n squared minus mn is equal to 0. Now the greatest common factor in n squared minus mn is n. So if I factor out n, I get n times n minus m is equal to 0. So now this gives me two equations. I get n is equal to 0, which is already a solution, and I also get n minus m is equal to 0. Now, going back to our original equation, we have m minus n squared is equal to m squared minus n squared. If n equals 0, I get m minus 0 squared is equal to m squared minus 0 squared, which turns into m squared is equal to m squared, meaning m can really equal any number. If m equals 5, then I have 5 squared is equal to 5 squared. If m equals 100, I get 100 squared is equal to 100 squared. So m can equal any number if n is 0. Now for here, I have n minus m equals 0. So if I add m on both sides, I get n is equal to m. Now, if I put this back into my regular equation, I have m minus n squared is equal to m squared minus n squared, and I'm gonna rewrite n as m because they're both equal to each other. So now I have m minus m squared is equal to m squared minus m squared. M minus m is 0, so I have 0 is equal to 0. And this means that they're both equal to 0. So now going back, what I'm going to do is do a different method to solve this problem. So method 2 is, first let's rewrite the equation. We have m minus n squared is equal to m squared minus n squared. And now this time, I'm going to again expand m minus n squared to m minus n times m minus n. And now from here, I'm going to rewrite m squared minus n squared as m plus n times m minus n. Because if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So now, as you see, we can simply divide both sides by m minus n, cancel these two out. So now I'll be left with m minus n is equal to m plus n. Meaning, if I subtract m on both sides, I get negative n is equal to positive n. If I add n on both sides, I get 2n is equal to 0, meaning n is also equal to 0. And if n equals 0, then remember how we already tried this out, m is also equal to 0. So these are my two solutions to this equation.